Architecture patterns are reusable solutions to common problems in software architecture design. These patterns provide a framework for structuring systems, making them easier to understand, develop, and maintain. By using architecture patterns, architects can ensure that systems are scalable, flexible, and robust, while also meeting the specific needs of their projects. In this particular section, we will explore five key architecture patterns, which are layered architecture, monolithic architecture, microservice architecture, event driven architecture, and serverless architecture. Let's start with layered architecture. Layered architecture, also known as end tier architecture, is one of the most common patterns used in enterprise applications. It organizes the system into layers, each with a specific responsibility, and typically includes layers such as presentation, business logic, data access, and database. Some of the key features include first, separation of concerns. Each layer is responsible for specific aspect of the application, promoting modularity and maintainability. Reusability. Components within a layer can often be reused across different applications. Ease of development. The clear separation of responsibilities simplifies development and testing. Use cases include enterprise applications where different teams manage different layers, systems that require clear separation between the user interface, business logic, and data storage. Let's look at an example. An e-commerce application might have presentation layer for the user interface, a business logic layer for processing orders, a data access layer for interacting with databases, and a database layer for storing that product information. Of layered architecture include easy to manage and maintain, promotes reusability and separation of concerns, and simplifies testing by isolating layers. On the other hand, cons include can become rigid and difficult to modify as the application grows. Performance overhead due to multiple layers. Monolithic architecture. Monolithic architecture refers to a single unified software application where all components are tightly coupled. In a monolithic system, the user interface, business logic, and data access layers are all part of one code base and are deployed as a single unit. Key features include single code base, all application functionality is contained within one code base. Unified deployment. The application is deployed as a single unit, making it simple to deploy and manage. It's tightly coupled. Components within the application are tightly integrated and interdependent. Use cases include small to medium sized applications with simple requirements, applications where performance is critical and there is a need for tight integration between components. An example would be a simple web application with a user interface, business logic, and database interactions all contained within a single code base and deployed as one executable file. Pros of this include simplified development, testing, and deployment process, high performance due to tight integration, and easier to debug and trace issues within a single code base. Cons include difficult to scale and modify as the application grows. Its tightly coupled component makes it harder to introduce changes or updates. A single point of failure can affect the entire system. Microservices architecture. Microservices architecture is a style of architecture where an application is composed of small, independent services that communicate over a network. Each microservice is responsible for a specific functionality and can be developed, deployed, and scaled independently. Key feature includes decentralization. Each service is autonomous and can be managed by different teams. Scalability. Services can be scaled independently based on demand. Technology agnostics. Different microservices can use different technologies and programming languages. Use cases include large and complex applications where different components need to be developed and scaled independently. Applications requiring frequent updates and deployments. Example can be an online retail platform with separate microservices for user management, product catalog, shopping cart, and payment processing, each of which can be developed and scaled independently. Pros include flexibility to use different technologies for different services, enhanced scalability and resilience, easier to deploy and update individual services without affecting the entire system. Cons include increased complexity in managing multiple services, challenges in maintaining consistent data and handling transactions across services, higher operational overhead due to the need for inter service communication and orchestration. Event driven architecture. Event driven architecture is a pattern where the flow of the application is determined by events such as user actions, sensor outputs, or messages from other services. In this architecture, components communicate with each other through events and services react to these events asynchronously. Key features include asynchronous communication. Components communicate through events, allowing for non blocking interactions. Scalability easily scales by adding more event processors or message brokers. Loose coupling services are decoupled as they do not directly communicate but rather react to events. Use cases include applications that require real time processing of events, such as financial trading platforms or IoT systems. Systems where different components need to react independently to changes or updates. Example can be a stock trading platform where buy sell orders, price updates, and notifications are processed as separate events by different services. Pros for this might be it's highly scalable and resilient, promotes loose coupling between components, making the system more flexible, and it can handle high volumes of transactions and real time data processing. Cons, on the other hand, complexity in managing and debugging asynchronous flows, potential challenges in ensuring data consistency across different services, and requires robust event management and monitoring mechanisms. Serverless architecture. Serverless architecture is a cloud computing execution model where the cloud provider dynamically manages the allocation of machine resources. In this model, developers focus on writing code without worrying about the underlying infrastructure, as the cloud provider handles all the server management for you. Key features include there's no server management. Developers are not responsible for managing servers, the cloud provider handles it for you. Scalability automatically scales with demand, changing only the actual usage. Event driven functions are triggered by events such as HTTP requests, database changes, or message queues. Use cases include applications with variable or unpredictable workloads such as webhooks or mobile backends. Event driven applications where different parts of the system need to scale independently. Example would be an image processing application where images are uploaded to a cloud storage service, triggering a serverless function that processes the image and stores the results in a database. Pros for this can be it simplifies infrastructure management, allowing developers to focus on the code. Cost effective as users are charged only for actual execution time. It scales automatically based on demand. And on the other hand, cons can be its limited control over the underlying infrastructure, potential cold start latency for infrequent used functions, and complexity in managing state and data persistence across stateless functions. So, architecture patterns like layered architecture, monolithic architecture, microservices architecture, event driven architecture, and also serverless architecture provide frameworks for structuring software systems effectively. Layered architecture offers a modular approach with clear separation of concerns, making it ideal for enterprise applications. Monolithic architecture is straightforward but can become rigid as the application grows. Microservices architecture promotes flexibility and scalability but introduces complexity in managing multiple services. Event driven architecture excels in real time processing and loose coupling, while serverless architecture simplifies infrastructure management, making it perfect for variable workloads and event driven applications. Understanding these patterns helps architects choose the right structure for their system based on the specific needs of their projects. So, if you have any questions on any of these architectures, leave them in the comments and I'll get back to you.